Hello everyone, this is Dr. David, or you can call me Margarita. Today we're going to expand on the arterial blood gas video that I previously posted. In this case, instead of us using the tic-tac-toe method for ABG interpretation, we're going to use the Rome method. Whichever method works for you when you get an ABG result for your patient doesn't matter. What matters is that you get the correct result. This is what Rome stands for. So the R stands for respiratory. So the R is talking about the CO2 level or the carbon dioxide level, which, as you saw from the previous video, is monitored by your lungs. The metabolic, which for the M of Rome, is talking about the bicarb or the HCO3, which is the parameter that's monitored by your kidneys. And when you're dealing with opposite or equal, that is referring to the relationship with the pH. For example, if you have a patient that has respiratory acidosis due to the retention of CO2, their CO2 level is going to be elevated. So it's going to be above 45, making it an acidic environment. And because we know that the pH and the CO2 is going to be opposite, if my CO2 is high, my pH is going to be low. So they're opposite of each other. Another example is with metabolic, which stands for the bicarb. So if I have a patient that's on metabolic alkalosis, I know that my bicarb is going to be high, but because it goes equal to my pH, the pH is going to be high. So in metabolic alkalosis, you're going to have a high bicarb and high pH. And I have 3 examples here that we're going to talk about. And just like we did previously, it's the same steps. So when you're trying to interpret ABGs, you're first going to look at the pH value and determine if it's normal, acidotic, or alkaline. Then you're going to look at the CO2 level to see if it's normal, acidosis, or alkalosis. And then you're going to look at the bicarb to see if it's normal, acidosis, or alkalosis. And you have the ranges on the other side of the board. So doing the acronym Rome, we're going to do the first example. So in this example, the pH level is 7.22. And looking at the normal range, which is pH of 7.35 to 7.45, this is below the minimum value that it should be. So it is an acid. So I'm going to put an arrow pointing down because it's low. Then we have the CO2 level of 55. So the range is 35 to 45. So that is above the maximum range that it should be. So is it acid as well? So we're going to point the arrow up because it's elevated. And the bicarb is 25. The normal bicarb range is 22 to 26. So it is a normal state. So this, I'm going to use the letter N, and I'll do that for all the examples to symbolize normal. So here we have a pattern. So the pH is low, which is an acid, and the CO2 is high, which is also an acid. So going back to our acronym of Rome, respiratory opposite, it matches the scenario. So this would be respiratory acidosis, going by that method of Rome. Now we're going to do the second example. In the next example, you see that the pH is 7.50. A pH of 7.50 means that it is higher than the maximum value it should be of 7.45. So it's an alkalosis. So here we're going to put this arrow to be going up. Then we look at the CO2. So the CO2 level in this example is 42. As you see from the normal range, it goes from 35 to 45. So it is normal. Then we look at the bicarb. The bicarb in this example is 33. The normal bicarb is 22 to 26. So it is above the maximum range it should be, which is alkalosis. So we put the arrow up. So here's the pattern. The pH is high and the bicarb is high. In Rome, metabolic, which is the symbol is for the bicarb, and this is CO2, metabolic is equal. So both the pH and the bicarb are going to be moving in the same direction. So this is alkalosis, because the first step is to determine where the pH is. So it's alkalosis, so it's metabolic alkalosis. And the CO2 is normal. Now we're going to do the third example. In this third example, the pH is 7.18, and the normal pH goes from 7.35 to 7.45. So we know that it is below the minimum level it should be. So we are going to put the arrow facing down. Then we're going to look at the CO2 level. The CO2 level for this example is 40. The normal range is 35 to 45. So that tells us it's normal. Then we look at the bicarb. The bicarb in this example is 18. So looking at the range, which is 22 to 26 for bicarb, we notice that it is an acid because it is below the minimum number it should be of 22. So we put the arrow down. And as you see, the pattern is that the pH is low, which is an acid, the CO2 is normal, and the bicarb is low. So this is metabolic acidosis. And based on this acronym of metabolic equal, both the pH and the bicarb are moving in the same direction. The only times that you are going to see, for example, in this problem, the CO2 not be normal and be abnormal is when it is trying to help the body in order to compensate. And that's called partial compensation. When you see full compensation, is that not only is the CO2 helping, but then the pH becomes normalized. So it's going to be within its normal range. At that point, you're going to have full compensation. Well, I hope that you find this video of great use to you. Make sure you like this video, share with your family and friends, and don't forget to subscribe to this channel if you haven't already. In that comment box below, make sure you leave your feedback on any questions that you may have, because I do look through them and I personally answer all of your questions. Okay, well, have a great rest of your day. Don't forget to press that bell for notifications. Bye.